My name is Jim Houts. I'm with Molecular Imaging Products in Bend, Oregon. I'd like to demonstrate one of the answers to questions that we get asked almost on a daily basis. And that is, the operator of the anesthesia device will say that their rebreathing bag is filling up like a balloon. Is there a problem with the animal breathing against that? And there are several issues to address here. One is the flow rate of the fresh gas going into the system. The second is the size of the rebreathing bag. And probably the most important consideration is the resistance that's on the pop-off valve on the rebreathing head. I have purposely opened this pop-off valve all the way. I have 2 liters per minute flow going into the system, and I have a reusable black rubber rebreathing bag that now is filled to this point such that it will not accept any more oxygen, and the excess oxygen will spill out into the waste gas management system. If you look at your manometer and see you only have a centimeter of water resistance or pressure in the system, which means we have a centimeter of water resistance on the pop-off valve, that is a safe value. If you see that you have 4, 5, or 6 centimeters of water resistance on your pop-off valve, that's going to be a problem for the animal to breathe against that. So this bag will reach this tension and that fullness, and after it has reached the resistance on the pop-off valve, it will spill into the waste gas management system. So in other words, even if you turn the flow rate up to 3 or 4 liters per minute flow, you would not increase any fresh oxygen delivered to the animal. It would simply be going out the pressure relief valve. In the previous demonstration, I showed you the relationship of the bag filling up when the tension on the bag equals the resistance on the pop-off valve. The gases will spill out of the bag into the waste gas management system. I used a black reusable rebreathing bag on that demonstration, and now I have a fairly flimsy balloon-like disposable rebreathing bag, and you can see that it's filled up almost like a balloon. And if I look at the manometer, I can see that I only have a centimeter of water pressure within the rebreathing head, and that means that I have a centimeter of water resistance on this pop-off valve that helps keep those gases within the rebreathing head. If we had a pop-off valve that had 2, 3, 4, or more centimeters of water resistance on it, we would expect that bag to fill up even more like a balloon, and that might be problematic for an animal to breathe against. At this level, 1 centimeter of water pressure in the system, 1 centimeter of water resistance on the pop-off valve, it is not a safety issue for the animal.